All right, welcome back, students. In this video, we're going to cover Module 11, Topics 4 and 5. This will be surface area, cross sections, and solid revolution. Standards for these topics is GR 4.6. Solve mathematical and real-world problems involving the surface area of three-dimensional figures, limited to cylinders, pyramids, prisms, cones, and spheres. GR 4.1, identify the shapes of two-dimensional cross-sections of three-dimensional figures. And GR 4.2, that's identify three-dimensional objects generated by rotations of two-dimensional figures. Excuse me. The objective for this lesson. One second. Okay, sorry. So you guys are going to find the surface areas of three-dimensional figures and identify the shapes of cross-sections formed by cuts to a solid, the three-dimensional objects generated by rotations of two-dimensional objects, and three-dimensional symmetries of objects. I promise that'll make sense somewhat by the end, or hopefully so. All right, so we are on page 12 of the Module 11 packet. Warm up. Sorry, I started the video and did not grab pencils and pens or anything, so we're just going to go with a pencil here for a little bit. All right, it says write the formula to find surface area for the following solids. Well, it also says it asks us to find it, so we're just going to do both. All right, so number one, what is the area of a square with side length of 12 inches? So I'm not going to go through drawing, but for a square, you know, all four sides are the same length. So area is either the side squared or it's the side times side, which is the same thing. So in this case, the side is 12, and 12 squared, let me just erase that because we'll just go down here. So 12 squared is 144, so that's 144 square inches. Remember, area is units times units, so it's units squared. And I'm going to just scooge up the page here, just so I'm trying not to make that camera mad. Maybe I need to stay back a little. All right, number two, a rectangle has a length of 5 centimeters, area of 330 square feet. What is the width of the rectangle? All right, so for the area of a rectangle, it's base times height. Now, in this case, they've given us the area, which is 330. They've given us the length, or we'll say the base, which is 10. Excuse me 1 second. Oh, sorry, I had to pause a second. Okay, so they gave us the length of the base here of 10, and they're asking for the width or the height. So, you know, it's length times width, base times height. Anyway, so we're looking for the height. It says the width. Just stay with me. So we're going to divide both sides by 10 because we want that height. And 330 divided by 10 gives us 33 feet. Our height is 33 feet. One second. All right, number three. A circle has a diameter of 12 meters. A square has a side length of 12 meters, which has a greater area. All right, well, we go back over here to number one. This was our square with 12 meters, so a side length of 12. So the area of the square is 144. So I'm going to put 144. Just put the S there. All right, so the area of the circle with the diameter of 12. So if the diameter is 12, remember the radius is half of that, that's 6. So to get the area of a circle, it's pi r squared. So pi, our radius is 6, so 6 squared. We multiply that out, and it is, hang on my notes, All I have on the notes is square. I believe it's 103.9, but let me just calculate that very quickly. So we got 36 or 6 squared times pi. Yeah, 113.09. Either way, and this is for the circle, so the square okay. So, got the square there. All right, number 4. A circle has an area of 12 square feet. What is the area of half the circle? Okay, well, if the whole circle has 12, what is half of 12? Hopefully you didn't need to do that, but if you did, it's 6. So the answer is 6 square feet, because it was 12 square feet for the whole circle, and half of that is 6. All right, let's scooch down the page here. All right, so lateral area. Man, I meant to bring my shapes home to put on the video. Dang it. All right, well, you guys that are in class, just remind me. I'll show you these shapes. This really aggravates me. I thought I had another set at home too, and I don't. But either way, we'll use the notes here, and that's probably better anyway, because that's what you guys have at home. So, all right. So the lateral area L of a solid is the sum of the areas of the lateral faces or lateral surfaces of the solid. So like down here, your lateral area would be this side and this side. It sits on the base at the top, and on the bottom, and then the base on the top is here. But it would be this side, and if it's 3-dimensional, the third side. And obviously I can't point behind there on the page, but hopefully you understand what I'm saying. The lateral faces of a prism are the faces that join the bases of the prism. So these join the top and the bottom, and there's one in the front, or one on the left, one on the right, and one on the back, because that's a triangle. It has a triangular base. The lateral surface area of a cylinder, so that's this guy down here. Let me just scooch up a little. See, it's the circular area. It has a circle on the top and circle on the bottom. Those are the bases, but the surface area, or the lateral area, is this part. Surface area, we'll get to in a second, includes the top and the bottom. But for now, we're just, that's shaded and that's not. That's shaded and that's not. That's shaded, that's not. Over here, it's all shaded because it'll all be included. All right, let's see. Where did I leave off? Okay. Yeah, so it's the curved surface that joins the bases of the cylinder. The altitude of the prism or cylinder is the segment perpendicular to the bases that joins the planes of the bases. Okay, that's a lot of words, but that would be like, I know this is dotted to show you it's 3-dimensional, but it would also be dotted to indicate that altitude, and we've seen that before with the triangles, but it's going to be the same with all the shapes. The height of the solid is the length of the altitude. So I've told you guys when it's drawn on its side, or when we're looking at these 3D objects, you'll see or really in any of those, when we have the dotted lines, that it indicates the 3-dimensional, but it also indicates the altitude. We'll get there in a minute. Let's see. A regular pyramid is a pyramid with a base that is a regular polygon. So a pyramid can have a triangular base, or it can have a square base. So the lateral faces of the pyramid are the faces that join the base of the pyramid to the vertex. So if it's a triangular pyramid, it's going to have triangular faces that are front, back, or left, right, and back, just like this guy. Let's see, the lateral surface of a cone. Why is it? Wait a minute, what the heck? Okay, no, that was cylinder up there. Sorry, I'm getting aggravated, but I forgot we have cylinders and cones. All right, so the lateral surface area of a cone. Now, in class, I held the little shape up here. It's on the next page, so I'm going to read through this, but we're going to go through all the shapes. It's kind of the bad thing to this lesson, the way it's broken up. But you guys know what a cone is. I mean, an ice cream cone, well, a cone in our world, or in my world of geometry, it has a point at one end and a circular base. So the curved surface that joins the base of the cone to the vertex, that's the lateral area. So it doesn't include the circle part of it. It just includes the cone part of it. For lateral area, when we're talking surface area here in a minute, it'll include that. Let's see, the height of the pyramid or the cone is the length of the altitude. So just like we were talking about before, which is the segment perpendicular to the base. And in their drawings, that makes it a little easier if you can see the altitude. Sometimes they don't have it on there, or if you're looking at a picture of a shape that doesn't include the inner workings, you have to know how to set up the shape, and we'll kind of go into that at the bottom of the page. Sorry, let's see. So enough about the altitudes. A sphere. So a sphere is ball, basketball, baseball, softball, tennis ball. It's a 3D circle. That's what a sphere is. It's a set of all points in space that are a given distance from a point in the center, called the center of the sphere. Just like the center of the circle, except it's circles all the way around. Again, I wish I had my little shapes. So let's go down the page here. Sorry. There we go. Okay. The lateral area L of a right prism is L equals PH, where H is the height and P is the perimeter of the base. All right, so we figure the perimeter, and then it's the height, because we only want to cover the shaded area. All right, the surface area is going to be S equals L, so our lateral area plus 2 times the base, because there's a base on the bottom and there's a base on the top, and we want to cover it all like covered in this picture. Oops, sorry. And notice our formula. So lateral area equals the perimeter times the height. And then here we have the surface area equals the lateral area plus 2 times the base, or perimeter times height plus 2 times the base, because L equals PH, we just substitute. So just showing you can use it either way. Lateral area L of a right cylinder is L equals 2 pi r, where r is the radius of the base and h is the height. So you see the radius of the base here and then the height, because we only cover that. And then it's L equals 2 pi RL, or h, excuse me. Surface area, so covering the whole thing. So we're going to do this. It's L plus 2 times the base. There's a circle on the top and a circle on the bottom. Or it could also be written like this, where you substitute L for its formula, 2 pi RH, plus 2 times the base, or because the bases are circles, 2 pi r squared, which is 2 times the circle. All right, flip over. Okay, 13. Sorry, let me get readjusted. Excuse me. All right, lateral area L of a regular pyramid is L equals 1/2 of the perimeter times the slant height. Slant height is the dotted line, and this indicates it goes up the side of that pyramid, where the altitude, like here, if this was sitting on the ground, it would be its true height. This, if it was sitting on the ground, it'd be like going up the side of the pyramid. All right, and it's half because these are pyramids. Because remember because they're triangles. triangle is 1/2 base times height, so it's 1/2 the perimeter here. That's why it's a little different. All right, the surface area. So to cover this guy, you're doing this. It's lateral area plus the base. It only has one base because this is a point. So your lateral area plus your base, or 1/2 of the perimeter times the slant height, which is that formula, plus the base. And again, your base area. We got to keep that in mind, the base area. So here, like for example, say each side was 6. Well, your perimeter would be 6 plus 6 plus 6 plus 6 because it's a square base. And then your, and then to get the area of this base, it's base times height, or because it's a square, side squared, either way it's 6 times 6. So your base area here would, for this just example, just plugging in 6, your base area becomes 36. Your perimeter was 6 plus 6 plus 6 plus 6, or 6 times 4, which is 24. And then L is just the slant height. I'm just trying to show you where we can plug those in. Sorry about the camera. Okay, lateral area for a circular cone. So right here is L equals pi RL. R being the radius of the circle on the base, and then L being the slant height because it's going up the side. This is the true height. Just making sure we understand the difference. So formula, L equals pi RL. Now surface area, so we're going to cover this and then we're going to cover the base. So it's L plus the base, or because that base is a circle, pi r squared. And it could also be written, you can replace L with its formula there. Either way, as long as you have the radius and the slant height, you can give the lateral or the area of the base. All right, scooching down the page here. All right, so surface area of a sphere. S equals 4 pi r squared, where r is the radius. So a sphere is a ball, basketball, baseball, and so it's a 3D ball. So it's 4 times that, your pi r squared being the area of a flat circle. All right, number 1 on the left. Find the lateral area and the surface area of the prism. Round to the nearest tenth. Okay, so this guy is actually sitting on its side so we could see its base. So this is the height. So our H is 11. Now, in order to find the lateral area, L equals the, so where we at is the perimeter times the height. Might help if I follow my own notes over here. Okay, so we need the perimeter. If we count the sides, this is an octagon. So let me write this where you can see it. Perimeter equals the number of sides times the side length. An octagon has 8 sides. It tells us that each side is 6. 8 times 6 is 48. So there is your perimeter. And then our height was 11. Multiply those. And we have a lateral area of 528. And that's inches squared. Should have been 48 inches, but we ran out of room over there. All right, so now they want the surface area. Well, so surface area is the lateral area plus 2 times the base, the area of the base. So we have 2 of these. Well, in order to get the base area, we need an apothem, because the area of the base is going to be 1/2 of the apothem times the perimeter. We have the perimeter over here, but we need the apothem. So the apothem would be from the center. I was off there, but the center, it splits this half. So each side is 6. So that puts this half as 3 and this half is 3. And then we would make a triangle because we would, using consecutive vertices, We have a 90-degree angle here. And because this is a radius, this is 6. So we have two sides. We need the apothem, or the third side. I'm running out of space, but I'm going to try to write it right here. So in this case, we have the C. It's across from the 90-degree angle. See? So there's your C squared minus A squared to get B squared, or actually we'll call this B because we want to make that our apothem. So C squared minus B squared equals A squared. C squared is 6 squared, which is 36. B squared is 3 squared, which is 9. Subtract those, you got 25. So A squared is 25. The square root of 25 is 5. So the apothem is 5. We already have the perimeter. That was 48. We need half of that to get the area of the base. We multiply those out, and our base area is 173.8. So let me plug these in. So the L, 528 point, nope, not point anything, good. Whew. Plus 2 times our base, which is 173.8. Multiply that, add that. Our surface area is 875.6, and this is, what was our inches? Yeah, inches squared, because it's area. So sorry we didn't take it the step down here, but we're running out of room. But you multiply 173.8 times 2, and then add that to 528, and you get this number. All right, number 2. Oh, God. Okay, never mind. Let's get this over. Thought I'd left it paused for just a moment. I was pretty scared for a minute. Okay, number 2. Find the lateral, and I know it says you do. The problem is we have these examples split up. So, I'm just going to do them. I think all the other teachers have completed this, so they get mad. I'm sorry. So first thing we're going to need here is our perimeter, and we have two sides of, and this is on its side too. So this is the height, because the bases are triangles, and then in the middle here they're all rectangles. So that's how we know. So we need this third side of the triangle. So going over here, A squared plus B squared equals C squared. This is across from the 90-degree angle, so that's going to be the C. So 12 squared plus 12 squared is your C squared. 12 squared is 144, plus 144 is 288. All right, that's the C squared. Take the square root of both of these. It's 16.97. We're going to round it to 17. So this other side, I'm going to put it here because they're the same. So that's 17. So first we need our perimeter. So it's 12 plus 12 plus 17. 12 plus 12 plus 17 is 41. So there's our perimeter. All right, now we need our lateral surface area. So L equals the perimeter times the height. The perimeter we just found, that was 41. The height is 8. Multiply those out. 328 millimeters squared. All right, so now we want the surface area. And again, I'm sorry this is all in pencil. This is what I got tonight in this video. So surface area for this guy is the lateral area, so the shaded parts. Now we need the base on the front and the base on the bottom. So L equals 2B. Let's go over here. So our base area, that's why I've got B instead of actually using area. I know this gets confusing, and I apologize. But so our base area is going to be 1/2 of the base times the height, because it's a triangle. So the base is 12, the height is 12. So 1/2 of 12 times 12 which is 144. Half of that, the base area, is 72. And take it over there. 12 times 12 is 144. Half of that is 72. So your L was 328. Then it's 2 times 72. 2 times 72 is 144 plus 328. Add those together, and you have 472 millimeters squared. That covers top, bottom, and all the way around. Okay, let me just move this just a little. Okay, number 3. Find the lateral area and the surface area of the cylinder round to the nearest tenth. All right, so for this guy, and it gets a little simpler now. Those two were a little hairy. So we have 2 pi radius times the height, though that's going to give us the shaded area, not the top and the bottom. That's going to come later. We have a diameter here of 10. Well, our radius is 5. I want to keep mentioning that because I do not want you guys to forget that come test time. So 2 pi, our radius is 5. Our height, because this is turned on its side, this is the top, this is the bottom, or whichever. But the circles are the bases. So the height is 9. So 2 pi times 5 times 9 is going to give us our lateral area, which is 282.7 square inches. All right, now we need the S, or the surface area, which is that L. Oops. The L we just got, the shaded area, plus, you got it, 2 times the base. Base area here is a circle, but we'll do it over here. It's pi r squared. Pi times the radius is 5 squared, 25. 25 times pi. I ended up just doing 2 times pi. Sorry, in my notes I did a little different. Hold on, let me get you this number. All right, so we got pi times 5 squared, which is 25. So that is 78 point, it's 539, we're going to say 54. All right, so our L was 282.7 plus 2 times 78.54. So 78.54 times 2 is 157.08. We're going to bring our 282.7 down and add them together. And it said nearest tenth. So we got 439.78, which is rounded to 439.8. And again, inches squared. Oops. Make sure we can see that. Yes. Sorry, my screen's in the way. Okay, number 5. Moving right along. Find the lateral area and the surface area of the regular pyramid. Round to the nearest tenth. And so for this one, I'm going to leave you the formula and let you guys work it the rest of the way. So for this guy, you're going to need, first we need a perimeter. So if this is 6, this is 6, and then the back side is 6. So 6 plus 6 plus 6 is 18. All right, so I got that out of the way. Your lateral area is 1/2 of your perimeter times your slant height. 1/2. I said I was going to leave the formula. I'm going to stop at this. 18 times the slant height is 8. All right, so work that math there. And surface area for this pyramid is, so we have only one base. So base area times the L. So you have the L right down here. Base area, I'm just going to help you out with that. The base area, because this is a triangle, it's 1/2 base times height. And oh boy, you do need the third side here if we draw here, I'll help you get this. So you see, this would cut this in half. So this is 3. Your hypotenuse is 6. Going down here, we're looking for this, which would be, we'll call it H because it's going to be the height here. So your H squared is going to be 6 squared minus 3 squared, because it's C squared minus B squared equals A squared, or whichever. So 36 minus 9 is 25. Your H squared is 25. We take the square root, and your height is 5. So plug that in, get your base area, and then plug that in, well, that plus that, and solve here. Okay. All right, number 6. Yeah, this won't be the rest won't take near as long. All right, number 6. Find the lateral surface area and the surface area. Sorry, lateral area. This is what keeps throwing me off. Sorry, I've done this lesson. This is the 4th time today. So find the lateral area and the surface area of the cone rounded to the nearest 10th. So first we'll find the lateral area. For a cone, our formula we just learned on the other page is the pi times the radius times the slant height. So for this, it's pi times 0.8 times the slant height of 2.2. We multiply those out, and we have a lateral area of 5.5 millimeters squared. Now, the surface area, of course I'm going too far, but that's the lateral area plus pi r squared, and I'm just plugging it in like that, so because we need the area of that one base or that one circle. So I'm going to scoot this over, so S equals L, which was 5.5, plus pi r squared is, I'm rounding it to 2. So 5.5 plus 2 is 7.5, and it's millimeters squared, because it would cover the cone or the pointed part of the cone and the base itself, the circle. All right, number 6, find the surface area of a sphere. It doesn't have a lateral area because it doesn't have a base. It's just a round ball. So for this, hold on one second. So S equals 4 pi r squared. See, our radius is 7.1, so it's 4 times pi times 7.1, squared. We multiply all of those out, and we get 633.5, again, millimeters squared. Write that a little better. Okay. A composite solid is a 3-dimensional solid that is composed of simpler solids. You can use the formulas for calculating the surface areas of prisms, pyramids, cylinders, cones, and spheres to calculate the surface areas of composite solids. So just like we did in the previous lesson, you can break down something that's really big into smaller chunks. That's what we're going to do with this. So the mailbox, and you guys know I can't draw. But we're going to unfold this mailbox, and I'm going to show you what it would look like if we unfolded it. You're just going to have to trust me, because I don't have any fancy animation that I can show you cool stuff with. I apologize for that, but I do try. Now, real quick, I'm going to steal my wife's little pens here because I have nothing else here. I need to show you what is congruent here and where I'm getting my numbers, because otherwise it'll make less sense than it's going to make, than I hope it's going to make here. But let's see what happens. Here, 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 here. Here, 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 here. Him. And then these guys. And then these would be 1, 2, 3, 1, 2, 3. Okay. So we're taking this mailbox and we unfolded it. So the sides that are 12, that's these, because it's going to be 3 rectangles and then 2 squares. The squares are 7. So everything that's blue is 7. Everything that's green is 12. And then these that are here, it's half of the side because of how this works out here. You just have to trust me. So it's 3.5. I'm going to try to make this make as much sense as possible. So here we go. So we're breaking this down into, we have 3 rectangles. And they want to know, and I didn't even read the problem, but manufacturer wants to know how much metal they're using to make these mailboxes. So we've peeled it all out, and this is what it looks like before they put it together. Got all our measurements. Now we need to know our surface area, because they needed to know all the metal, because the door is metal, and then the back that doesn't open is also metal. So again, we have 3 rectangles. These rectangles are 12. Let me just put this as 12 times 7. That's the base area, or that's the area of this rectangle times this rectangle plus this rectangle, or 3 times that. And we're going to add that, so we have 2 squares. Those squares are 7 times 7, because it's side times side, or side squared. Plus, so you're going to have to trust me here, it's, this side is 12. Because it's a half a circle and here's the other half, it ends up being a whole circle, but we go 12 times 3.5 pi, 3.5 pi. Just trust me, okay? And it's actually approximate, because we're approximating this. But when we do all of our math, so 12 times 7 times 3 plus 7 times 7 plus 2, times 2 plus 3.5 times pi times 12, and we get that. I know it's a lot, and please see me in class or send me a message if you need some further explanation. All right, scooching down the page here. So cross sections. A cross section is an intersection of a solid figure and a plane. The plane of the cross section formed by the intersection of the plane and the figure. It depends on the angle. So right here, this thing has a square base. If you cut it across, it's going to be square here, and it's going to look like a smaller pyramid up here. If you cut this in half, it'll be a triangle, because that's what the sides are. And this bottom would be a rectangle, because it's, half a pyramid. And over here, it's a little different, because, it's all about the angle. All right, at the bottom, 3-dimensional symmetry, plane symmetry. So a 3-dimensional figure has plane symmetry if the figure can be mapped onto itself by reflection in a plane. So if you had a rectangular cube, so square on each end, but rectangles in the middle, if you were to cut it in half with a plane, you'd have 2 squares. All right, flip it over, page 15. All right, so number 9, choose the correct representations for planes of symmetry. Select all that apply. So in order to be symmetrical, it has to map onto itself. So if you cut this it's rectangles on the side, squares on the top and bottom. If you cut it in half horizontally, it will match. If you were to cut it in vertical half, so going straight across that square, you would have two smaller rectangular pieces, and they would fit to each other. And if you go vertically this way across the square, you would do the same. So the answer for this would be A, C, and D. The other two, the way you cut it, it would not map onto itself. All right, number 10. How many planes of symmetry does a regular pentagonal prism have? So I can tell you, as far as symmetry goes, you can cut it in half this way. Well, it's not straight, but if we cut it in half that horizontally, it would map onto itself, or it'd be symmetrical. And then the way I understand it, for each vertice, so it'd be, if that's pentagonal, that would be 5 plus the 1 horizontally, so 6. Let's see. Scooching up the page. Give me just a moment. All right. So describe the shapes of the horizontal and vertical cross sections. All right, so if we cut this thing horizontally, you see that the bases are circles. So horizontally, it would be a circle. Vertically, since the bases are circles, it would be a semicircle on both sides. It would be a shape that would be, well, it would look like the mailbox from earlier, because it would be a semicircle and then a semicircle on the other end. I'm just not that good at drawing. All right, so over here, so we have a sphere, which is 3D circle. So any way you slice it, if you slice it this way, it's a circle. I know I sliced vertically and wrote horizontally, but if you slice it this way, it's a circle. If you slice it this way, it's a circle. All right, a solid revolution is a solid figure obtained by rotating a plane figure or a curve around an axis. The shape of the solid of revolution depends on the location of the axis and the shape of the plane figure or curve being rotated. So three-dimensional symmetry, axis symmetry. So three-dimensional figure has axis symmetry if we can take that figure and map it onto itself with a rotation of 0 to 360. So let you see here, we rotated this around, it's a cone. All right, so identify the solid of revolution. So if we curl up this square, and I can't show you here, but if you curl it up, it curls into a circle on top, a circle on bottom. Looks like that, and that is a cone. If you take this and go all the way around, looks like that. Actually, that's not a cone, that's a cone. Good grief. What happens when I start thinking ahead? This is a cylinder. That's a cone. All right, bottom of the page, and this is the end of this lesson. Circle each item with axis symmetry. So this pot, if you cut it down the middle, it would be the same shape on both sides. This looks like a snake, but no. Here, the Capitol building, because it's symmetrical, you could fold it onto itself. The donut, not the duck. Over here, same thing, this light bulb. The tree may have longer limbs on one side than the other. The drum's a circle. It's like a bird, but no. And then an hourglass if you cut it this way. All right, so that's it for this lesson. If you got any questions, let me know in class. Till next time, have a good night.